Thank you very much. So this is very much a tech talk. I'd like to thank my back office staff, Jonathan Drake, Bob Harms, Kathy Holfeld, and Chris Parsons for helping me devise it. It's actually inspired by our work helping people do data management across distributed offices in small international oil company centres. Our own company is spread, we have 70 people who are spread across 7 different locations. And as we work with small exploration offices in places like Malaysia and Vietnam and so on, we come across a lot of data management issues where people have to have access to large data sets such as SegWi files. Sorry, we seem to have the automatic advance running in the slideshow at the moment. So where they have to share large data sets such as SegWi files, list files and things like that, but they don't have access to the data structures, the network structures to share them correctly. And it also, interestingly, they don't necessarily have access to a lot of local IT support. So we've reached out for using a lot of technologies to share information, which our clients have, and today want to share some of the experiences in those technologies with you. So Petros's own operations, we managed to do a lot of our work using intranet and VPN applications. A lot of the time-sensitive things like frontline applications are handled really well. But there's a lot of other information which we need to have across those offices in our company, which we simply can't share effectively on an intranet. So in particular, things like large test data sets, so the big batches of SegWi, the large database instances that we have to work. We actually maintain something like 20 different database instances in our company. And when we look at that data that we're trying to share around the world, we sort of see that there's a footprint in terms of dynamics, in terms of volumes, in terms of the structure and the security, which all influence what kind of technology we can use to share that across different offices. Because when you try to shoehorn information into sharing technology, you'll find that you get constraints, which mean that one sort of technology doesn't meet all needs. So there's the issue of how dynamic is the data. Does it change on a daily basis, such as operational information, or is it static, such as a SegWi file? What's the shape of the data? What's the volume? Does it come as a big batch, or is it lots of little bits? What's the structure of the data? Is it fragmented into lots of little bits, or is it come in large swags? And of course, what's the security and confidentiality requirements? So there's a lot of different aspects you have to take into account when you try to apply a technology to change it. And there's many different technologies you can use and reach out to try to share information, from file system duplication right through to cloud-based storage. And as a small company, we focus very heavily on trying to use the cloud-based storage, which is really what a lot of this paper is about. So the most obvious way of sharing data across work groups is to simply make a copy. And we've all done this. We know it's easy to do, and it's very reliable. But it also becomes very labor-intensive if you want to synchronize data across collaborative work groups. So if you're trying to work on the same project in 2 different offices, you end up reaching out for things like USB drives, or as we do sometimes, to ship our databases or SegWi data sets around the world, is we simply reach for those big terabyte drives you can buy and stick them in a courier bag. And we know if you do that, you have a high risk of losing data, and there have been some very high-profile data losses with companies losing laptops recently in the world. So there is a big risk of data loss, and there's also obviously a huge problem in version management. And so to get around that, there is a technology called optimized wide area networks. And this sort of technology involves putting in a whole bunch of hardware and software which attempts to optimize the use of the internet to meet the needs of sharing data sets across file systems. We actually tested one of these systems that, as I said, came in a lot of boxes with a huge amount of instructions. And we found that the need to tailor this sort of technology to meet those many different shapes and configurations and topologies of data we're trying to support was too difficult. So we abandoned that particular exercise. So we moved into trying to use cloud-based storage. And if you read all the advertisements, this is the answer to all your problems. You throw the data up into heaven, and somebody up there will look after it. Now, one of the first things you discover when you move your data into the cloud is that a lot of cloud-based systems aren't going to give you a straightforward file system. And those of us who've been doing computing for 30 years are very file-oriented. We like file systems and folders. And a lot of cloud-based systems don't actually give you file systems and folders. They use the non-hierarchical document management, because to try to create value add, they say, we're going to give you more than just data, we're going to give you knowledge. The trouble is that creating knowledge from data is a fairly time-consuming process. It requires analysis, it requires metadata, and things like that. And whilst it's possibly worthwhile in some instances doing all of that analysis to create wisdom, when you're really just trying to share SegWi files, often that effort is not worthwhile. And so one of the first differentiators is to make sure that you're going to get the type of folder storage that you really want to have. One of the systems that we have tried does actually provide you with a hierarchical file system, so it appears to create a folder which looks like a Linux folder or a Windows folder. But what's interesting is when you put certain sorts of data into those cloud-based folders, it doesn't necessarily always behave the way it did when it was back in the Windows world or the Linux world. And there's various reasons for this, but it certainly indicates that the topology of what happens up there is not the same as what happens down in the world we're used to. So we have reached out to use the document management, the knowledge management approach for cloud-based storage for several of our workflows. And one of the instances where it works really well is in the management of training data sets. So there's a particular workflow we have which is similar to a number of other documentation requirements that you might have, where all of the attributes of knowledge management work well. It's got file locking, version control, and so on. And it just happens to be the nature of the workflow meets the particular deliverables of that particular tool. And because it works so well, we thought, well, let's try applying this particular tool to other workflows. But we found that didn't necessarily lead to instant success, because the tool is quite difficult to learn. It has a very non-intuitive user interface, and it takes a lot of time designing the metadata indexes and taxonomies. I don't know if some of you have probably created SharePoint repositories and so on, and had different levels of success with it depending on the effort that people have put into building indexes and so on. And certainly not everyone wants to spend that time doing the analysis. And one of the worst things about some of these knowledge management technologies, and I've heard this reflected by somebody else in one of the coffee breaks, is that somebody who puts a file into it because they're enthusiastic to share the file with other people, they come back later on, open the location again, and the file's not there anymore. And that's because these things have a strange way of identifying knowledge. The information's still there, but it's just gone into a more clever place. So one of the other differentiators we find between the different tools we use is how it synchronizes information. When you're trying to collaborate with data across a work group in different parts of the world, you want to make sure that people's changes in one part of the world are reflected in the other part of the world. And that means that the file system has to be synchronized. It has to be brought up to date somehow. And the way you control the synchronizing of data across cloud-based systems is very, very different between different applications. And we found it is, in fact, one of the key differentiators in how effective the different technologies work. And it's actually one of the things that's been a bottleneck in the effective rollout of many of the tools. And in fact, the WAN optimization stuff we actually dropped because of that, problems we had with that. And the various things that affect the synchronization behavior, and it's quite a lot of different things that affect it, is what's the actual global network configuration, what's the logical design of the synchronization process. We're going to go through all this in a bit more detail later on. What are your data management standards, and how does the individual actually relate to those data management standards? So synchronization is a complicated thing, and it's a core piece of the use of cloud-based data systems. First impact we talk about is what's the global network. When you put your data management into the cloud, you sort of assume I'm giving responsibility for this to a vendor, but you're not actually giving it to one vendor. You're actually putting it into a very, very complex electronic ecosystem of routers and network cables and firewalls and jurisdictions and commercial things. And each one of those things along the path can influence what happens. Some of the big disasters that we've heard of recently in cloud-based storage are because of the failure of one component of the system. And some of the examples that we've discovered, for example, is our ISP changed the performance plan, and it can be some subtle variation in how the ISP gives you access to the internet that changes the effectiveness of your solution. Another interesting thing is that computing devices that our remote users are using aren't getting bigger necessarily. So, for example, our current generation of laptops has smaller drives than the previous generation because we've moved to solid-state drives. And the difference between 300 and a 600 gigabyte drive is quite significant. So in Petrosys, we've started to use both public and private cloud systems. So a public cloud system, a thing like Dropbox, is easy to get at, but it's not very secure, so we've also implemented some private cloud systems. And one of the things that you will discover is that the public cloud systems, they run like a rocket in comparison to the private ones. So where we've put in a private cloud system, we've found we've had to invest quite a lot in our own server hardware. The way you control the synchronization, the actual user interface you have to use is another big differentiator. How do you select? How do you time? What's the offline functionality like? And we found that the different forms of control by the different applications is really important in the effectiveness of the solution that we put in place. So in using some of the public cloud systems, we found that some of the servers have suddenly become swamped out because of unexpected attempts to synchronize things. We found that work groups which haven't been governed particularly well, the files have been moved or renamed by somebody in another time zone, another part of the world. And in the case of the private clouds, the user interfaces are very often very, very obscure. So we found instances where somebody thinks the file has been synchronized, but it hasn't, and you get somebody sitting on a plane expecting to edit their PowerPoint, and as the hostess says, you can now use your electronic devices. The PowerPoint's unfortunately not there, or they're running the old version. So synchronization controls are very important. And the way you want to control it, you need to create some corporate standards which work around the problems of the synchronization behavior. So good governance, setting of corporate standards around each particular workflow is really, really important. And you can put in place the best corporate standards that you can dream of. You can have the greatest governance procedures. But the problem is, if one of your remote users is confronted with poor internet performance, you can't really blame them if they don't conform to the corporate standards. And once a user feels disenfranchised, you start to get all sorts of problems. The old locally unmanaged copies, personal desks, reaching out for technologies they shouldn't be. And one of the worst things about getting a non-performing remote sharing system is the fact that your team members drop out of the team. They stop participating. They say, but you never talk to us. So corporate standards, really, really important. I won't go through this slide. We've heard a lot about data governance and corporate management systems today, so you can read about this when you see the things. The other aspect about cloud data management is the legal aspects, the jurisdictions, the ownerships and controls. Again, if you read the paper that's been distributed with this conference, in-house counsel wrote an entire paper about this, which I've compressed into 2 minutes. When you put things into the cloud, so if you want to move something from Glasgow to Perth, you might assume it goes up there and it flies beautifully in hyperspace and comes back down again. Unfortunately, it doesn't do that. It goes through all sorts of different places, and you really have very little control over the route that it traverses. And so it passes through many different vendors, through many different technologies, and through many different jurisdictions. And each of those paths has the opportunity for data scraping. Somebody can steal your data. And you also become liable to the jurisdiction of the various places that your data is passing through. So you do need to be aware of the legal aspects of putting things in the cloud. You don't want to be accidentally exporting or importing data from Iran or Cuba, for example, if you're the United States. And you also have to be very aware of the fact that if you put in place a corporate data management, data sharing system, which your users are going to get used to using, that they don't apply it, for example, in Vietnam or Indonesia, to accidentally export data from a country where you're not supposed to be doing that. So another aspect, obviously, of security is user authentication, and we're all familiar with the problems these days of people using their usernames for all sorts of commercial things, and the fact that reputable organisations like the Australian Tax Office store passwords and usernames in unencrypted form, from which they get hacked and get distributed from time to time. So in summary, what actually works for us at Petrosys? Out of all of these different types of data, we haven't found one solution that actually resolves all of our problems. And like a lot of you, we actually use many different tools. So we use public cloud for less sensitive information, such as marketing materials, which we need to share with external third parties. We use the private clouds for corporate records, technical collaboration, training. And we use both the ones that offer us a hierarchical file system as well as the ones that offer us document management tools. The document management side of things, it's interesting because for each form of technical collaboration we have to sort of devise a different workflow with different data management procedures. And in practice, and again, this has been confirmed that many of our colleagues in our oil companies do this sort of thing, we still use a lot of FTP. We still use a lot of thumb drives. We still use a lot of terabyte drives to share things. For example, very large technical data sets you do have to ship in a courier bag. And things like our nightly builds, which are about 600 or 700 megabytes, we push up and down the line every night with file transfers. So in terms of recommendations, just to run through this very, very quickly, the key differentiators that we find are really the fact whether you're going to use something like a wide area network, optimized WAN technology solution, or various software-based solutions. Is the system you're going to use just simply trying to replicate a file system, or is it trying to add a layer of knowledge management on the top, which can be an advantage or a disadvantage? Sorry, that decided to switch me off. What is the synchronization and the offline behavior? How do you do the authentication? And I'll leave the recommendations up there in lieu of the little slide that people put up marked questions, and open the floor if any of you has any comments on your own experiences about this, or any questions. Thank you.
Do we have any questions from the floor?